Okej. Jag tänkte vi skulle snacka lite om hur man lär sig saker. Hur många här har mer än 100 browser-tabs öppna? Hur många har mer än... Jag vet, det var ganska många som hade 100. Hur många har 200 browser-tabs öppna? Han outad av sina kollegor. Hur många har 150 någonstans? Det är någon. Ja. Varför har ni det? Varför har ni 100 tabs? Varför har ni 50 tabs öppna? Vad har ni på dem? Någon som vill berätta det? Jag vet vad jag har på mina. Det brukar vara så här typ. Ja, men den här artikeln vill jag läsa. Och den här artikeln vill jag läsa. Och den här artikeln ser bra ut. Och den här jäveln ska jag faktiskt kommentera på. För det här är så fel så att jag blir irriterad. Någon som har det? Det här ska jag läsa. Läser ni det någonsin? Alla 100? Hur många läser ni? Hur många stänger ni bara ner? Hur många läser ni? Hur många försvinner när ni startar om datorn? Men alltid kvar, ja i och för sig. Då ska jag vilja fråga. Du svarade ju här. Förlåt, vad heter du? Lisa. Lisa, du har läst alla dina artiklar. Hur många läste du hur många läste du ungefär i förra veckan?
3.
Vad hette de?
De handlar om React.
Nej, men vad hette de? Vad skrev de om React?
Lite hur man kommer igång och hur man kör.
Kan du ta någon paragraf ur? Nej, och det kan inte jag heller. Jag läste också ganska många artiklar för jag har precis samma problem. Jag kommer inte ens ihåg vad de heter. Jag kommer knappt ihåg vad de handlade om. Och jag tänkte vi skulle prata lite grann om hur vi faktiskt undviker det. Jag är uppvuxen ungefär här. I en plats som man kan kalla för absolut ingenstans, mitt i Sverige. 97 invånare. Där jobbade jag för bland annat Debian. Jag skrev kernelkod i C++ och byggde mobilbasstationkod. Tyckte att Microsoft var nog faktiskt bland det värsta i hela världen. En stor del av den teknik jag har byggt används idag i renspårning. Så nu börjar ni förstå liksom hur mycket på landet det här var. By the way, does everybody speak Swedish? Sorry. So, let me back up. Or actually, this is just an introductional one. I'll just continue. There's no topical information yet. It's super sorry. Oops. Didn't mean to be non-inclusive. So anyway, most of my technology ended up in either you were being used for GSM, mobile communication, or tracking reindeer. So that is basically how much out in the bush we were. It is roughly here. And I then met a girl at a party, and I moved to this little bit more south. I went to Dalarna. And I had to find a job. And I had the same job for quite a while, and I was very, very good at my job. So I went to Capgemini, and I interviewed. And it turns out that passing a C# interview when you're very, very good at C++ is extraordinarily easy. However, it also turns out that if you have absolutely no idea what C#.NET is, it is also very easy to go to an interview, talk to people about code, and think you're being hired for a C++ position. So I signed a contract thinking I was going to do C++ development. They signed a contract thinking I was going to do C#.NET development. There was a bit of an issue. So I turned up to my new team and realized that there's been a mistake. And I was horrible at C#. I had never used it. I've written a few lines of Visual Basic 6.0. That was all I've ever done with Microsoft Technologies. I never even used Windows that much. It was in 2007. And I started to noticing this in a pretty bad way because while I did know a lot of C++ and I was a very good programmer, my team was hurting because, and people were starting to treat me actually quite nasty because I was not contributing to my team because I didn't even know how to do a proper cast in C#. I didn't know about boxing, unboxing. I was doing mistakes, right? It went so bad that I realized at one point that if I would quit this team, I'm not talking about somebody else replacing me in this team. If I quit this team, they would be better off. They would write code quicker with less people in it. That is not a good place to be. But sucking is the first step to getting better. So, what I did was that I started reading blog posts. Oh wait, sorry, that's next slide. I'm going too ahead of myself. No, so what I did, well, no, actually, sorry. What I did was starting reading blog posts. I read a lot of blog posts. I spent 2, 3, 4, 5 hours every night just reading through blog posts and trying to get to know C#, and I was learning so slowly. I was learning extraordinarily slowly. Very little that I didn't learn at work while writing actual code that compiled and worked were useful. So I would like to share with you the framework that came out of this that I now use to learn things and to remember things and to memorize things that have brought me from being the absolute worst performer in a C# development team to teaching C# all over the world to developers, and to finally, now today I work for Microsoft as a C#.NET expert for architecture. That sounds pretty good, right? Yeah. So we can all be really much better. How many people have programmed more than 10 years? How many people have written C# for more than 10 years? Is there anyone I can mess with a little bit? Oh, you can mess with you. So you've written code more than 10 years?
No, I haven't.
Okay. All right. All right, I'm going to do this way. Can anybody tell me the maximum value of an int32 in C#? Very good. 2 billion.
2 billion 6.
500,000 over, but you're close. I mean, honestly, I've done this presentation before, and nobody's ever even been able to say 2 billion, so a round of applause. It is 2,147,483,647 if you're interested. I'm also going to talk a little bit about how you can actually memorize stuff like this in Brilliance in meetings, but it's perfectly pointless. All right, so the way I started out trying to figure out stuff was blog posts, right? And that didn't work for me. And I read a lot of blog posts because, like, I interviewed all of my colleagues. Like, how do you learn? What do you do? How do you learn, Johan? You read books? Do you watch videos? Do you read blog posts? Do you do courses? Do you go to conferences? You seem to go to conferences.
Mostly by being exposed to problems.
Yeah, trying and error and writing code and that sort of stuff. All right, nice. How do you learn?
I don't remember.
You don't. That's a good answer. So, but that was what I did. I went to everyone that I work with. It's like, how do you learn? How do you learn? How do you learn? How do you learn? And most people, they learned by reading blog posts. Like, that was the thing you did in 2007, 2008. You read blog posts because everybody had a blog and everybody was blogging and reading blogs and that sort of thing. And so I sunk myself into this, and I just got nowhere. And then, out of pure luck, the wife of one of my colleagues was at a dinner for work. And I spoke to her quite a lot, and she introduced me to Hermann Ebbinghaus. And Hermann Ebbinghaus, he is the father of modern memory knowledge, so to say. And he devised something called the Ebbinghaus forgetting curve. And so this is like the most important part of the entire presentation. So, like, if you want to leave after this, you probably learn most. But what Ebbinghaus proved repeatedly with lots of people is that if you read something, if you read a blog post, you will forget 80 to 90% of everything you read within 6 days. That's how our brains work. We do not retain information. We forget it. So that works pretty well. I can't remember blog posts. Lisa cannot remember her blog posts. That sort of stuff, because we read them once and then we click, I read it, close the tab. But what we actually should do is keep the tab open, and then the first time we should read it, then we should read it the next day. And what's really important about getting these is the spaced repetition, right? We can't read them 3 times just like that and say we've repeated them. We have to give our mind time to process this between each iteration. So what he suggested in his original white paper it wasn't called white paper then, but it was a thesis, was that you first read your material, then the next day you read your material, then for each repetition you wait an additional day. So your second repetition is on 2 days from the second repetition is 1 day from the first time you read the material. The second repetition is 2 days after that. The third repetition is 3 days after that, and so forth. And he found that by doing 3 repetitions, he could retain as much as 75% of all the information that he read. And the way he tested this was by memorizing or reading nonsense text. So he invented basically something that sounded like the minions from, Evil Me, or and then he memorized that language, and he did pretty well. So it does work, and I've tried this myself many times. So repetition is the most important part to actually remember what you do. But there are other ways as well. So learning by doing is also something that we tend to do, and this has worked extraordinarily well for me. But there is a problem with learning by doing. The person that did this are probably quite pleased with their work. So this is called law of the instruments. Like you probably heard, if all you have is a hammer, everything looks like a nail. And this is actually Maslow, if you remember the guy who invented like the needs stare and everything like that. He also defined this, the law of the instruments. So the notion of this golden hammer is like familiar technology or concepts applied obsessively to many software problems. And these are where anti-patterns come from. How many people here are game developers? None. All right. So if I would say singleton to somebody who is an experienced developer, you would say it's an anti-pattern or a pattern? How many think it's a pattern? How many think it's an anti-pattern? Yeah, pretty much both. And that's the thing, like you can say, if somebody said it's a pattern, usually they're working with something that need pools or that needs resources in that sort of way. It tends to be game developers because they need to work with bullets that are being generated, and you need to reuse these objects because they want to render them and that sort of stuff. But if you say it's an anti-pattern, you're most likely an enterprise developer and who have seen somebody who read the first section of the Gang of Four and thought, this looks nice, and then implemented it everywhere. If you look for singleton implementations on GitHub, there are some really horrific examples. Just telling you that. So, what I mean by this is that if the only thing you do is learning by doing, you're very likely to not learn anything, or at least you will cement a bad behavior. So the combination of these things tends to be you read something, you try and implement it, or the best combination of these things so far, according to psychology, is that we read something, we then try to do it, which is a repetition in itself, but it's a different form of repetition, which brings the material you read better into your long-term memory. Then you read and repeat it again, now with the found understanding of doing the problem, which means that your mind will be better searching for the topics in the text. It will be better to retain the important pieces. And then you do it again, and that's so forth. This is a way that we can use learning by doing, but also to store the information we have read in a very effective way. I am, by my own accord, a pretty good C# developer. I don't think I would have become as good. I'm a better C# developer than I'm a C++ developer. And I've done some pretty high-core C++ projects. And one of the things that I think gave me the possibility to be this was that I sucked at C#. But I could also admit it to people because they knew. There was no point in me hiding it. I cannot do a cost. Tell me what you're doing. And then you have something called the beginner's mindset. And this is actually a really important thing when you're learning. If you go in and say, should we talk about React? I, of course, know about React, but do tell me a little bit what you know. And I have to constantly try and hide and mask that I have not a simple idea what she's talking about. Then how am I going to ever be able to relax enough to actually listen effectively to what she's saying about React. So I can take in this information, store this information, process it, and ask intelligent questions. And all my brain processing is being used to just mask the fact that I have absolutely no clue to what we're talking about. I have read the biography of Nikola Tesla since I made this quote, and I'm not sure I really like Edison anymore. But it's a good quote. The third way of kind of cementing what we have been learned is what I'm doing right now. I am teaching it to others. So let's say we read something, we read it again, we experimented with it, and then we go and teach it to somebody. This forces our mind to go from something we call from internal structure, or the psychologists at least that I've looked in the books, they call it that we are structured information to enter our mind. But when we have to think about dishing it out, when we're supposed to give it, our mind has to restructure the information so that we can actually tell it in an order, which means that we prioritize the information and we work with this sort of information. And it makes it so much easier for us to access it. So everything that we teach is, our brain kind of goes, yeah, you know what, I'm going to go and put this in ROM because it's important, cache, because this is important. I want to go down to the database and actually look for that stuff. Let's cache this because we're going to teach that stuff. And here is something for some of you. If you go to a conference, there's absolutely very, very small possibilities of repeating something, which means that your possibility to repeat something is to take notes. So not taking notes is preparing to forget. I like the uncomfortable laughter of the people who are not taking notes. But there is other benefit as well of taking notes. How many people of you are as old as me or older? How many people are above 35? Let's not go with my age. And most of us are above 35. So we didn't have computers or phones when we went to school. We had pens. When you were learning in school, you were holding a pen. So this is kind of funny. So if I would tell you to remember 25 different numbers like this, you would probably do 5 or 6, which is normal for a human being. If I would do this, your brain would now actually remember more numbers because it remembers that when it was learning, it held a pen. It works. Repeatable studies. It's not like a great bonus, but it's like 4 or 5%. An additional thing is that when you're writing it, you're activating other parts of your brain. So writing it down actually makes your brain. So think of it as you have to put it through your API. It has to go in here and you have to process it to be able to put it here, which means that it's easier for you to remember what the person is actually saying, and your mind will structure it to make sense to you. Make sense? Good. So these are like all the sort of tricks that we have. But if we actually want to learn a topic, because this is just to remember things that we're reading in kind of like this rambled up world we live in. And if you're anything like me, if you look to your sources of information, they're overflowing. We have books that we haven't read, right? And we have books on the same topic that we would like to read. Lots of them. And we have blog posts in tabs, some of us over 100 tabs, and we have, all these sort of things, and it's just jumbled. And we have no idea what we should read next. And that is not effective. So actually, effective learning does require some planning. And you should split your information that you're taking into 3 different steps. So you split the information into essential information, into abstract information, or into conversational information. So some people say to me, okay, but so I only need the essential information. No, you don't. You don't. So the way your mind works with neurons, and this is an extreme oversimplification, so please do not quote me on this. But the way your mind works when it's to retain something is that it wants to hook your memory into other things that you already know. So the more you know, the easier it is to learn. If you know 5 languages, even if you're learning a language that has nothing to do with those other languages, it's still easier to learn a new language. because your mind has things to put them on, to hang them on. So abstract information are things that are concepts of this. Like, it's not essential, it's not factual, it's an opinion perhaps. But these opinions might actually collect with things that you already know. So you can put them into, and it can actually help you retain this essential information. Conversational information is things that you kind of talk about, things that you discuss when you're having a beer, that sort of thing. They are also important because they give us the ability to open up a conversation about technology and either get to teach the material, or we can ask more intelligent questions and get people to give us better responses and kind of talk to this stuff about for us. So what is essential information then? So these are the undisputable facts, right? This is John Skeet. Now, I mean, the undisputable facts are the authoritative, and people like, how many people, by the way, know who John Skeet is? Okay, not so many, but that's okay, because I have a slide about it. So, undisputable facts, like the ground is hard, that sort of thing. Gravity works. These sort of things, right? If you type this, this will happen. That sort of information is essential information. Things you need to know to be able to write your program is essential information for code. Like design patterns is probably not an essential information, but unboxing and boxing in C# is probably essential information for learning C#. However, if we could take a step up and say, I want to learn to program effective enterprise applications, great. You probably need to learn C#. That's an essential information in itself, which will generate other needs for essential information. But in this case, design patterns probably also is essential information to learning to write enterprise applications. So it really depends on where you're going to go with this. And I will show you an example how I would have broken down one of those problems actually later. But people like John Skeet then. So normally I do not think we should have heroes, and we should not take information from people that are opinions. Like, because when I say something to you, that is my opinion. I'm not citing my sources here, even though I have them. But you should definitely go and look for yourself. This is not essential information. This is abstract information you're getting from me, right? Because you cannot check if they're true or not. But John Skeet and people like him are those people that he's the 0.01% overall Stack Overflow answerer of C# questions. It's very hard to Google a common C# problem going to Stack Overflow and not finding a comment by John Skeet. He works for Google, by the way, as C# developer. Really, really good. I mean, he is so good at C# that people write comics about him and C#. And when you start to get to that level, yeah, what you know is probably good enough to be, regarded as essential information. So the same thing goes for like the people who wrote the language. Like if you're going to go to C++, and you listen to me and you're going to go like, yeah, that's probably not true. But if you're going to go to the actual people who went down and learned the language, who by this way, if you go to Bjarne Stolstrup, who wrote, most of the C++ discussion back when I was, younger, he rates himself as a 7 when it comes to programming C++ in a scale from 1 to 10. So, they're also pretty good sources because they're no bullshit there. So now, abstract information, these are the boarding topics, right? We cannot really define them to be true, but we could Google them and we can check it out and that sort of stuff. Common knowledge, if you like. Everybody knows that you shouldn't use singletons. Not really true, but everybody knows, and that sort of information. Information basically we're using to connect essential information into long-time memory. And the last part is conversational information. Like coffee discussions, interview questions, and good to have when Google is down. Coffee discussions, people tend to, why should we do coffee discussions? Well, because coffee discussions is very, very important to bring knowledge to your team. If you have these little tidbits that you can throw in, it's like be like, hey, what do you think about the notions of using integers as a storage method for cache values instead of using decimal in C#? Some banks have moved over it, I've heard. And we can have a discussion about this, right? And we can go, nah, I think that's stupid. Okay, why do you think it's stupid? And you can learn about your teammates, and you can get all these sort of different concepts into your head that, and I know I'm starting to sound like a broken record, help you retain information in long-time memory. And this is because learning rewires the brain. There's a really good white paper by Nathan Spreng. He has done these sort of studies, and if you download these slides, there's actually a link to his study, which is free. So, when you're a beginner, you focus on something. You focus on a problem, because you have to solve the problem. When you're a beginner, you write, okay, console, down right line, parenthesis. All right, I need to use that key. What was the name of that character? All right, yeah, quotation mark. And then I have to write hello world. Should it be a comma in hello world? Does it matter? You know, that sort of stuff. We have to focus very hard on what we're doing. As you become more and more advanced, writing console right line hello world is something you can do with very little problems. And, you know, of course, it gets more and more advanced from there. And that is because your brain has deemed this information to be more important. It has actually created connections between this information and your fingertips. This allows you, as you learn more things about your language, to become much more autonomous, to be much more creative. So if you have ever experienced being in the flow, that is also working with something you know very well. Like when when the day just disappears and you solve so many problems, right? And you just work really well. That is also a sign that what you're working with is something you've learned very well. And it's not really true that they rewire the brain, but they get faster, like the neurons fire faster. And it's all detailed very well in his white paper, so I'm not going to stand here and bore you with this. But the point is that if you're working with a programming language, it makes a lot of sense to learn the kind of quirky bits about it too, to learn more about the programming language, because it's going to help you write the other parts of this programming language much faster, and it's going to be easier for you to remember things when you're working with it. So let's look at our attack plan for learning. So when I started to do C#, so it would have looked something like this. The essential information became the C# language specification. It is an undoubtable fact. This is the specification we're using to define the language, right? So that's kind of like how I looked at it. Then using the Visual Studio development environment for C#, also is released by the developers, released by Microsoft. Yep, probably good sound information about how to use Visual Studio. And then the C# programming guide, because this is how Microsoft envisioned us to write C#. So, but then we get into all these sort of abstract information, like, okay, what is object relational mapping? What is model view controller? What is inversion of control? And 60 more topics about everything regarding programming, that sort of thing. And you kind of get to this, and you realize that, oh, okay, so inversion of control, yeah, probably abstract for the actual language C#, but for programming enterprise applications, yeah, probably essential. And you can go and then kind of map this as, okay, the impact of reading the entire C# language specification is probably very high if I can remember it. But the complexity of reading the entire C# language specification, anybody tried to read it? It's excellent if you can't fall asleep. It would take forever. However, using the Visual Studio development environment, it would probably take very little time because it's very short. But it's not really that good at learning me how to write, And then, okay, reading the C# programming guide, yep, very valuable, not so hard. Okay, so probably that's what I'm going to start with, because you want to have as much use for your time as possible. And then you go through the entire list, and you do this sort of thing for that. Somebody called me out last time for why I call boxing and unboxing conversational information, and that is because boxing and unboxing, I would say, is a typical interview question that you need to be able to reason around. So it could both go for essential information, right? Because you have to understand it, because it's a huge performance impactor. If you're doing constant unboxing and boxing and that sort of stuff, like, you need to understand it. But it's a very different thing from programming it and understanding it when you're writing code and being able to explain it. So the way I reason when I put it as a conversational piece is that I wanted to be able to very well talk about these things, right? This is how it works, because I wanted to be able to do it in a programming and interview situation. So you're going to have these sort of things like abstraction, encapsulation, polymorphism, inheritance, same thing, right? It's essential to understand these concepts. So it's not like essential is the thing that is most important and conversational is not. But it's also kind of like, how do I want to be able to communicate with it? Essential is information that I want to be able to use. Conversational is information I want to be able to communicate about as well. Because, you know, if you're noticing somebody who's really not getting abstraction, you want to be able to teach your fellow teammates about abstractions. So it's something you actually have to train more. So conversational information can be something you have to train more on than essential information. So after we qualified all this information, we put it into sort of this priority queues, we go into something called the actual learning, which the first thing I tried to do was measure. How much do I know about this topic? So I just sat down with a blank piece of paper and I wrote down everything I could about the topic I was going to immerse myself in. Just as much as possible, just little keywords. So I know, okay, I know this, I know that, I know this, I know that works like this, and, you know, just as much as possible for, you know, half an hour or something like that. I then went in to read some of the articles. I went into to try them and then repeat, of course, you know, and did all the repeat and everything. I tried to find somebody who know less than I, so I could teach it to them. And I went back and I measured again. Have I learned? Have I learned something? Am I now more knowledgeable? Can I get more stuff about this topic from my head? Oh, sorry. And if I couldn't, I had to change something about this topic because this topic was not sticking. And this was the kind of the way I was moving around with this constantly. Measure, read and repeat, do and apply, and teach it. And then measure.
Was the typo intentional? Me assure.
I'm sorry?
Was the typo intentional? Me assure instead of measure? Because I like the me assure.
Probably not, no. It's probably just a typo. Oh, I didn't even know it. No, I didn't see it. Sorry, that's just a typo. So I started to looking for some tools then, because this was starting to become pretty complicated. I was seeing pretty good results, but it was starting to become quite complicated to keep track of all this stuff. So the two tools I used from the start was Anki app and OneNote. So in OneNote, I started doing this sort of, you know, memory hacks for one thing, which I'm really interested in. As you might have noticed, as I've memorized int max 32, but that sort of stuff. And I sort of started to taking information from all these essential and that and making into a schedule. Like this week, I'm going to read this material. Then I'm going to repeat it on this day and that sort of stuff. So I had some information that I had to read, so that I couldn't really get away from it. I should really do some training every week, and that also helped me when I was able to kind of schedule this sort of stuff. And then I just used OneNote to kind of like schedule everything like this for the essential information and reading material and abstract information and that sort of stuff. The second one is, of course, the Anki app. If you can see here, then I have the Create Anki book for 0 to 999. Anki is a very nice app. So it's a questionnaire app, a Flipkart app. Do you use Flipkart? Use Flipkart? Use Anki? Right on. So Anki allows you to create a Flipkart for anything you like. And as you're using it, it gives you these very nice statistics on how well you're performing when it comes to questions. So you can create a C# questionnaire, or you can find a C# questionnaire, because a lot of the books on Anki is public, and you can try them out and see, okay, I didn't do so well. You study for a while, you go back and say, oh, I did well, better now, and you get statistics over a time then, and until you are roughly at this place where you can say, okay, I know this topic now. And the app is super simple in itself. It's just, question and answer. So in this case, I'm trying to memorize the Dominic system for how to convert numbers into letters, which is just, okay, 9, okay, that's PB, and that's that sort of stuff. Another app that I've been just starting to use quite recently is Memrise, which also helps you a lot. It's marketed towards languages, but there are also there's lots of like programming languages and that sort of stuff in there as well that you can use to memorize. And all this stuff is free. Cool. So let's see how much we remember from this session, shall we? If you read something once, how much of it will you have forgotten in 6 days? 80 to 90. Very good. That's why we repeat stuff, right? Because that helps us remember things. Learning by doing is only effective if... No, but if you have learned a new way of doing it. So that's kind of like if we're just doing things, we're going to do them in the way we know how to do them. If we do not bother to read, if we do not bother to learn new topics, learning by doing becomes cumbersome and will take a very long time because we will continue to solve problems. If you've ever tried a mathematical problem by Euler, you know Euler.org? You and I have the same hobbies. So if you have tried that, there's lots of these mathematical problems, which I tend to introduce to students. And it's quite funny because you can see that some people Google the actual mathematical problem and find the algorithm, and then they try and implement the algorithm. And some people do not do that, and they try and solve it with brute force. For each, and somebody went like, "Yep, here's the answer." And I was like, "How long time did the execution take?" 2.5 days. So I thought, okay, you solved it, but wasn't really in the spirit of the problem. We have some really nice demos if you want to try and brute force it, though, because it's super fun to try cloud services, which we've done, and you just throw them on like a batch service, which executes it on top of 100 GPUs, and you can do this, 2.5 day things in 20 seconds, which is kind of fun, but it's still not actually as fast as using the proper algorithm. Now, teaching someone. Why should we teach people? Very good. It reformats our brain to make it easier to learn. So, and a little knowledge goes a long way. Like if we learn conversational topics, if we learn abstract topics, this will give us, an easier ability to learn things. And having a plan is the key factor to successful learning. So, what are you guys going to do now then? Next time you have to learn something. You're going to make a plan. Very good. Are you going to repeat it? Yeah. Excellent. I would also advise you that you actually check up your sources, because so far all you have is a white guy in 35 years old who's been, babbling. It might as well have been lying to you for 40 minutes to fill a slot. So I would like to close a little bit about tools. So I recently went to a conference, and I had the great pleasure of sitting on top against a very famous person who unfortunately didn't want me to quote him, so I will not say the name. But a very famous person when it comes to neuroscience. And he told me the thing about browser tabs, and this is why I asked it in the beginning. So how many browser tabs do you have open before it effectively hinders your job? 7. Very good. If you have 7 tabs open, your mind will focus on these things. If one of them is a social media account, it drops to basically that only tab. That tab will hinder your work performance because you will go to that tab, you will look at that tab and that sort of thing. He also told me that extraordinarily interesting. If you have more than 5 things that you're focusing on work, you are roughly as effective as somebody who is constantly smoking pot and trying to do one thing. And this is not even a joke. They have tested this repeatedly in states in the US that allows you to smoke pot. Somebody trying to solve one problem on a computer programmer, smoking marijuana is as effective doing one thing as somebody who's trying to do who's actually trying to do one thing while thinking of 5 things or more. So if you're a project manager and you want to double your effectiveness, the easiest thing in the world is go in and tell your developers, this is the most important thing, please work on only this thing. It's been proven in studies over and over again. I can show you loads of quotations about this. So if you're a product manager, you just want things to go really quickly. Just go and say, this is the most important thing, I'd really like you to work on just this thing, thank you. The problem with that comes because things intervene and things work together, and there's a lot of problems with that approach as well. But if there are things like that, then giving your developers the sort of satisfaction of knowing that, okay, I'm working on the only thing that currently is important, is a very, very good mental trick. Which also means that when you're thinking, I need to pick up the kids, and I need to figure out what to make for dinner, and I need to figure out what to wear, and I gotta go to that wedding, and I gotta do this, and that, which is modern life, we become less effective. Which is why, a lot of famous people have one set of clothes to wear. Which is why a lot of people try and limit how much they think about stuff. So that's why we have tools. We're not here to have tools that get in our way. Like if this OneNote slot doesn't help you, throw it out. My point is that if you find something interesting, either forget about it or put it into your learning path. Are you learning C#? Why are you reading about React? If you're learning Java, why are you reading about C#? All these sort of things, right? So focus your learning. If you have 20 minutes to read something, then read something that you have decided that you're going to learn. Not something that just popped up in your flow because your friend just wrote about it or something like that. Because you're not going to remember it, because you're not going to repeat that blog post that you have in your tab. Oh yes, I forgot I had one more slide. Flashcards are good. So, and like I said, these tools may not be working for you, but please do try them. They have made me, I would say that being a really lousy C# developer have given me the best career I could ever dream of. And I'm super happy to be here and talk to you about this today. Thanks for listening.